Yeah. Okay. Thank you everyone, and thank you for attending this talk. So today this is a resource paper called Beyond Accuracy, Investigating Error Types in GPT-4 Responses to USMLE Questions. So this is a collaboration with IIT Kharagpur. So I am from IIT Kharagpur, PhD student, and L3S Research Center, Germany, and University of Michigan. In that way. So you have already heard that GPT-4 and other LLMs, medical or non-medical, are doing very good in medical question answering, and this is one of the benchmarks that is used, this MedQA USMLE. So what we try to understand is the following. So let us first understand what an USMLE is or what a medical question is. So it is typically like you are given a medical scenario. For example, here there is a 29-year-old woman, some demographic information followed by the condition that she is facing, followed by what are the, say, some initial tests has been done and what they have observed. And then the questions typically are, what is the next diagnosis, what is the treatment, what intervention should we go? And you are provided this multiple choice question. So this is the setup that we start with. And what we have the reference correct answer, that is ground truth. And we have GPT-4 predicted answer, there is a particular option A, and say ChatGPT also predicts. So this is, and how do we calculate the accuracy that was reported is that we take the one that is predicted by the answer, say A, versus if it matches it is a +1, otherwise it is 0. So this is the standard how accuracy gets calculated. But what is the problem of this method? It is that we are only depending on how GPT-4 gives that final option, and we do not know what is the explanation or what is the thought process behind which GPT-4 reached us. So, and this is nowhere considered if you see the literature on the GPT-4 part. Second is that there is no detailed work on an error taxonomy to understand why GPT-4 makes those mistakes or their error categorizations present or not, right? We try to target this specific portion. So what is the simplest way to start with? So we tell GPT-4, okay, why you are answering. So that's why we have this simple prompt, say, please explain your answer and why the other options are wrong. And then what happens is, nicely, that we have this huge response that is given. So the first part is, it explains that answer, why it chooses answer A, and second, why the other options are wrong, right? So this is the typical setup that comes with, and this is one of our main contributions. We run this GPT-4 over this 10,000 questions, and we provide these responses. And what are the key takeaways? And then I will go through one because we don't have much time. First is we show that just reporting accuracy is not enough. You have to go through the explanations that are provided by the model and develop an error taxonomy behind it also to exactly evaluate whether it is doing good or bad. That's why in this you saw there's a detailed response around 250 words on average. We develop an error taxonomy in collaboration with medical experts. Third, we give out this unlabeled data set of GPT-4 responses. We have many variations of it, plus we label around 300 of them involving around 45 medical experts all around the world, and we give this good annotated data set at sentence level. So we'll come to that, but it is like you have a document, the response, we do this error type annotation. So this is the overview that we have this question and prompt. What we do, we run it through this 10,000 training set, and out of them we got responses for around 5,000. This is in August we did last year. And out of them we choose the ones where GPT-4 is doing wrong, say around 919, this is typically like 20% around. And then out of this 919, we talk with the medical experts, medical students and doctors and come up with this detailed error taxonomy, right? So this error taxonomy is one of our key contributions along with this resource where we typically divide it into this reasoning error, knowledge-based error and reading comprehension error. Because of time, we'll only just say one about the most important is this sticking with the wrong diagnosis, but others are also derived from prior work, right? So given this overview, what we additionally have is that this something known as drift. That is, if GPT-4 gives some prediction now, we know that it updates. And so we again ran the same setup in January 28 very recently, and we also provide that resource. Along with that, we also provide this concepts as well as predicates that are obtained from it. So I'll just quickly go over through it. So this was our annotation setup on the Potato platform, where the annotator was given this option, a detailed response, and he was able to choose each option and then annotate a span out of it, right? And this was a timeline that we involved a lot of medical students to come up with this annotation analysis. And this is what a typical span of the resource will look like. It will be a very granular, it is like sentence level, not the document level. And each response can have, it will be a multi-label portion in that way. So it can have, like for example here, the 2 different options. And the 2 main conclusions were the reasoning errors were the most frequent, but the most important is that GPT-4 responses was found to be reasonable in that way. And so this brings to the end of my talk is that you can read the paper for more details, but this huge resource can be utilized for better understanding how LLMs work. And so it is beyond, you have to go beyond accuracy and also like analyze the rationales behind it. So by that I conclude my talk. Thank you very much for listening.